So we're in Unit 1, Lesson 4 of absolute value equations and inequalities. And today we're going to look at graphs and transformations. So by the end of the unit or lesson, you should be able to graph on a coordinate plane an absolute value equation. And you should be able to write an absolute value equation from a graph. All right, so let's first talk about absolute value functions. All right, so we're going to learn how to graph y equals the absolute value of x. All right, so we'll take a look at this table of values to help us out. So our domain is going to be all real numbers because we can plug any value we want to into x. So our domain is going to be all reals. And we're going to look specifically at the values of -4 to +4 for our x. So remember, taking the absolute value. So if I plug in -4 and I take the absolute value, I get a +4. When I plug -3 into the absolute value of x, I get +3. The absolute value of -2 is +2, 1, 0, and we can complete the pattern. All right, so those are my functions. So no matter what value of x I'm plugging in, positive or negative, to the absolute value of x, I get a positive value. So take a look at my graph. If you notice, I have a V shape. Okay, our graph is a V shape. It's two rays to be exact, where they meet at our vertex, which in our parent function is at the origin 0, 0. So our domain we said is all real numbers because we could substitute any x value we want into it, positive x or negative x. What about our range? Okay, our ranges are y values. If you notice, this graph does not dip below the x-axis. So there are no y values that are less than 0. All right, so our range is going to be y is greater than or equal to 0. So this function is our absolute value function and can be written as this. F of x is equal to the absolute value of x, or just y. All right, and the vertex is the point where the function reaches a maximum or a minimum. In this case, it is a minimum, meaning it is the lowest point on the graph. If our absolute value graph tips upside down, which we will look at in a bit, we will have a maximum, the highest point of the graph. All right, so what is the vertex of this one? It's 0, 0. It's the origin. And later we're going to look at shifting our graph around, so the vertex won't always be at the origin, but in our parent function of just plain old y equals the absolute value of x, it is. Okay, so here's a basic equation where we can be adding in numbers, multipliers, and all that good stuff to help move our graph around. So y equals a times the absolute value of x minus h plus k. That's our basic outline for an absolute value function graph. So we can substitute values in for a, h, and k. All right, you won't always have numbers for all three of those locations, and each one does something different. It moves the graph in a different way. So let's start by taking a look at k. K is a number that's being added or subtracted outside the absolute value bars. And when that happens, it tells you how much your graph shifts up or down. And it shifts in the expected direction. So if we look at this blue graph over here to the right, all right, I have the function y equals the absolute value of x minus 3. Notice the minus 3 is outside our absolute value bar. So that's telling me that my graph is moving down 3. All right, so once again, a number being added or subtracted on the outside of my absolute value shifts that graph up or down in the expected direction. If it's a negative, it moves down. If it's a positive, it moves up. All right, and you can see from the pink graph to the blue graph, it shifted down 3. The vertex shifted down. The vertex is now at 0, -3. Okay, so we can also say that this number right here is the y coordinate of your vertex, of that middle point. All right, the next value we'll take a look at is our h value. H is a number that's being added or subtracted inside the absolute value, and that tells you how much of a graph shifts left or right. It talks about its horizontal movement. And what's important to know is that it's going to be moving in the unexpected direction. For example, looking here, I've got x plus 2. When I say it's moving in the unexpected direction, meaning plus 2, you would initially think it's moving right, but it's not. It's moving left. All right, and that's because the original equation has y is equal to x minus h. So really, it's x minus a -2, okay? Moving it left 2. So if you just remember the number outside shifts it up or down in the expected direction, Positive goes up, negative goes down. The number inside shifts it sideways in the opposite direction. So when I see a +2, I'm really going to move to the left. If I had a -2, I would move that to the right. Okay, and so the opposite value of this is the x value of the coordinate. And so, of course, if I have two shifts happening, if it shifts to the left and up, I will no longer have a 0 in either coordinate for my vertex. And the last one we're going to talk about is our a value. A is a number that's being multiplied by the absolute value. And what that does, it affects the graphs and how much it stretches up or how much stretches out or how much it's compressed. It changes the width or the dimension of our absolute value. Okay, it can make it tall and skinny or short and fat. Easiest way to think about it in absolute value is it's the slope. And if we take each line one at a time and think about our slope, to a degree, it helps make sense. So also keep in mind, if that a value is a positive, it opens up just like in a parabola. If it's negative, it opens down. It's a frowny absolute value. All right, so right here, if I have just a -1 in front, it's not changing how I'm getting from one point to the next. It's still 1, 1, okay? But I'm going down 1 and 1 to the right. I'm going down. It's opening up my absolute value to the bottom. All right, so let's take a look at some graphs. All right, so we're given the graph of the parent function in green. It's already put there for me. I'm sorry, it's put there in gray. All right, so we need to describe the translation of y equals the absolute value of x minus 2 and then sketch our new graph. So our h value is going to be a +2 because remember, what's inside here is the opposite. So my h is a +2. So my graph is moving right 2 places. Okay? So if I want to graph this, I can take my graph and shift it right 2 places. There's no up or down movement because there's nothing being added or subtracted on the outside. I just shifted it to the right 2 places. All right, looking at this graph, y equals the absolute value of x plus 2. So my k value is 2. It's on the outside. So that means my graph is going to be moving up because when it's on the outside, we move in the expected direction. So I'm moving up 2 places. So I can take this graph, no sideways movement. I just move it up twice. All right, so given our graph of the parent function, we're going to describe the translation of y equals the absolute value of x plus 3. All right, so let's think about this. It's the opposite of a negative, or just think you're going in the other direction. So since it says +3 inside, our h is going to be the opposite of that. It's going to be a -3. So we are going to be moving left 3 places. So if you just remember, take a look inside, go the opposite direction that that number is pointing, you are good to go. So I'm moving left 3. All right, and then absolute value of x minus 1, it's on the outside, so I go in the expected direction. So my k is -1, so I'm moving down 1 place. Shift it down 1 place. All right, so let's talk about our a. Now we have -1 in front. So a is equal to -1. So what that's going to do is it going to reflect over the x-axis. Really, it's just going to flip it upside down. Okay, so we haven't really seen numbers yet that are going to change the width of it. We're just talking about flipping it. Oops. Flipped the wrong one, but you get the idea. All right, there we go. Flipped it upside down. All right, so when all is said and done, a value in the front of my absolute value sign, the a, indicates the graph has been stretched or compressed. We'll get into bigger numbers later and really talk about how that changes it. But for now, if it stays positive, it's opening up. If it's negative, it opens down. The H on the inside tells you how much the graph shifts left or right in the unexpected direction. So if it's a negative number, you're actually moving to the right towards your positives. If it's a positive number, you're moving to the left towards your negatives. And the number being added or subtracted on the outside, the K, tells you how much it shifts up or down in the expected direction. All right, please bring any questions to class.